Okay. Welcome once again, everyone. I am JT Dean. I am Director of Individual and Major Giving at Chesapeake Conservancy. Welcome to our webinar that we have going on this morning. We're excited to showcase a lot of the work that we do here. This we're talking about here for our data science work at our Conservation Innovation Center. This is truly the core of most of our conservation programs here. And we want to make sure that we can show you all what we're doing here, but also how you can be involved in the work that's going on. So for those of you who are new to Chesapeake Conservancy, we are a nonprofit here based out of Annapolis, Maryland. And our ultimate goal is to conserve 30% of the Chesapeake Bay watershed by 2030. So we do this through several different ways. We do it through conserving lands and working with data science to be able to pinpoint exactly where the most ecologically valuable places to conserve. Also conserving historical and culturally significant places around the Chesapeake Bay, and also allowing people to have access sites to the Bay. Only 2% of the Chesapeake Bay is accessible to the general public, and we want to expand that because we believe that if people have more access to the Bay, they'll be more inspired to want to protect it. And also, we'd love more people just to be outside and to enjoy the outdoors with us here. But like I said, all of our programs here really connect back with the Conservation Innovation Center and our data science and artificial intelligence programs here. And there are many different levels and different programs and research that's going on through this work that we're happy to share with you. A lot of it has to do with the work that we're doing with the federal government and state governments here. We work very closely with the Environmental Protection Agency in providing them the data that we're able to produce here so they can make good policy decisions. And we'll touch on that. But mostly we want to touch on here about the work that we're doing right here in your communities and work with the municipalities and individuals, farmers, on ways that they can enact good and valuable land management practices so that they can play a role in the conservation process here and what we call democratizing conservation. So I have several different speakers here that are lined up that are interested in sharing some of their work with you. But first I want to note here that we will have a question and answer session at the very end. So if you have any questions, you can put them into the Q&A button over there. So our first speaker, I'll go over here, different bios. We'll have Steve Stork, who is acting director of the Conservation Innovation Center here. The next speaker will be Rich Patuk, who is retired, was at the EPA and is now on Chesapeake Conservancy Board. Katie Walker, our geospatial program manager, and Dr. Michael Evans, senior data scientist. And we'll be able to share some more information about this great program with you. So I am going to stop sharing my screen. I'm going to turn this over to Steve to talk to you a little more about the Conservation Innovation Center team and some of the work they do.
Unmute myself. Great, JT. Thank you very much. And I really appreciate everybody's interest came today to learn more about the Conservation Innovation Center. I'm actually one of the newest members of the team. I've been here just since August last year and actually acting director since September. So I'd just like to go through a little bit about what the Conservation Innovation Center is. We call it CIC here, just for short, and some of the main things that we do. In researching this, I actually discovered that we're actually celebrating our 10th anniversary, which is a pretty big deal. Joel Dunn, our president and CEO, came up with this concept, and what he had completed a master's down at in North Carolina, and what he wanted to do was to leverage this tool that he had just learned, GIS, in the conservation realm, and really trying to understand, what land was, what the condition of the land was, what development was going on there, and leverage some of the high level imagery and data that was available in this decision making. So, the overall purpose from that time was to make this tool available and to support conservation and restoration, both practices and policies. So we operate at a bunch of different levels, but our primary tools are maps, and then maps made from primarily high resolution geospatial data. And we'll get into that a little bit in a minute. So what we do is we create tools and products at various scales, from the watershed scale, incorporating the 7 states from New York to Virginia, and all between, as well as all the way down regional and even parcel level, with some of these tools we do. And we create the data and put it in the hands of practitioners, farmers, natural resource managers, but also decision makers on a regional and multi-state level, state level. But our goal is to get this data in a manner, in a format, and in a way that these folks can interact with that information to make decisions without having to worry too much about the technology. The technology part of it is our job. And then we do whole level, as Rich will go into, and some others, partnerships with agencies, conservation organizations, communities, to build on this really actionable data. So just a little bit of background on the CIC team and the projects. I'll let Katie and Mike go into more in-depth on some specific products and programs that we're doing. But just to give you an idea of what it takes to do this type of work, we have a staff right now of 12 folks. That's one of the largest GIS focused staff of any nonprofit, regional nonprofit conservation. So we're pretty proud of that, and we're actually growing with a grant from the Kerr Foundation. We're going to be adding 2 junior data scientists here in the near future. We're going to have 2 interns that are funded through the Bureau of Land Management to work on some local recreation access GIS work. So we're constantly, and we work with a lot of partners. We have contractors at universities and some private contractors that are specialists in their areas to augment this. We manage about 20 projects, sometimes more, sometimes less, but a lot of juggling with that. And a lot of, some of those are 5-6 month projects. Some of those are multi-year projects. So a lot of administration management. Katie is one of our program managers. We have one other. The types of projects we work on, as I said, parcel scale, conservation planning maps, regional analysis tools. One of the ones we're working on right now is sort of future solar siting, which is a big topic for us that Mike will talk about, I think, a little bit. Land conservation projects, acquisition tools. So local conservancies trying to figure out where the best place to plant trees, to do watershed protection, to do farm planning, but also to purchase right-of-ways and protection conservation right-of-ways and easements. Our primary product that Katie will talk about here is land cover and use classification. So what is happening on the land and what is changing on the land, and then resource inventories and data access portals to try to give folks, again, all this data that we're working with, give them access to it at the level that they're comfortable using it. Talk about a little bit the funding types. We have a lot of government grants. We have cooperative agreements. These are some of our federal partners. We also do fee-for-service contracts directly with different organizations and nonprofits. And then we do a lot of our work with charitable donations. 2 terms that you're going to hear is precision conservation. Because we're able to utilize some remote sensed imagery, we are actually can process images that are a square meter on the ground. So we can see what's going on a square meter on the ground with 18 inches of elevation accuracy. We look at current historical land use, land cover, water resources, and interpret this information to really enable informed decision making. Part of that is democratizing data, making data available to all levels of society. And we create a bunch of different products at a bunch of different levels, combining very disparate data sources So we make it easier, and we try to make this available to folks free of charge. We go out and find the money to make all this, and we have an agreement with most of our providers that this is data that folks can use free of charge. So I will stop sharing my screen and allow Katie to take over from there.
Steve, we're going to bring Rich in actually. So
Oh, sorry about that. Sorry,
No, no
Rich.
problem. So thank you, Steve. Appreciate it.
No problem.
And I'm going to bring in Rich to talk about here more of the work that we're doing on the greater scale, working with specifically with the EPA. Rich is a former staff member over at the EPA and is now on our board of directors. He's more than just a board director. He's part of our family in more ways than one, who's been helping us out, coming through the office, working with Steve and the rest of the team on making sure that we're set up for success and offering his guidance. So we're incredibly grateful for him and all of his work that he's done at making sure that we have the strongest team here possible. So Rich, I'll pass it over to you.
Thanks, JT. Appreciate that. So prior to 5 years ago, when I retired, I worked with the United States Environmental Protection Agency, but more importantly, I worked for a state, federal, local, business, academic, agriculture, nonprofit partnership called the Chesapeake Bay Program Partnership. And over the last 34, 40 years, that's been guiding the efforts to try to work with local governments, with state governments, with NGOs out there to restore the Chesapeake. And I was fortunate to see over that time period, the Chesapeake and its watershed starting to come back, getting more healthy, et cetera. The last couple of years, seemed like we hit a glass ceiling, and we're starting to roll back as well. So one of the reasons why I joined up with the Chesapeake Conservancy is not only being one of their biggest clients with my prior agency and partnership, but also a big user of the information out there. Was I think the Conservancy and the work they're doing with their immediate partners have the opportunity to transform what's happening out there as well. And if you get one message from what we're describe here is the work that you're seeing here is transforming what's going to be possible in terms of Chesapeake Bay restoration out there as well. So I want to give you a little bit of feel for being an end user of this information, coming from the Conservancy over the last 10 years, and now as a board member, why we think this is going to be working very well. So here's what we start out with. What the team at the Conservancy starts out with. Here's the imagery that they look at out there. And then here's what we used to deal with until about 10 years ago at 30-meter resolution. Here's what we were developing into our models. Here's what we were presenting to the public. Here's what we were working with farmers, with municipal authorities out there as well. You can't work with something like that. Look at the difference. Look at how the Chesapeake Conservancy and their partners work transformed the ability to look at the landscape out there, land cover, land use, to something like this. I can't tell you how important it is when you're looking at 64,000 square miles, 6 states, 1,600 local governments, 87,000 family farms out there, to try to have them understand where they fit within this large watershed, within their small catchment basin, within their town or their city out there as well. Here's the same set of imagery that we used to work with, that I work with modeling teams, with municipal authorities, with state agencies, federal agencies, again, at the 30-meter resolution, in this case, in a more rural area out there as well. But thanks to the Conservancy and their partners, here's what we now see out there as well. I can't tell you how important it is for people to have confidence when you're working at large landscapes, but you can also not look in their backyard, but you can look at their local landscape and understand how they fit in there, what they can do differently for their land, how important this land is to conserve. If you're a farmer or you're a municipal planner, how to ensure that those lands are doing the function they need to, but they're also helping protect biota out there. They're helping protect local water quality conditions as well. So here's another reason why I'm excited about what's the opportunity out there. We had, for decades, had never been able to accurately map across the 7 states that make up the Chesapeake Bay watershed wetlands. Along comes Mike Evans and his team of folks starting to bring artificial intelligence to bear. And now we're starting to create maps where we were either underrepresenting, as in this particular case, where wetlands were located out there, using a tremendous amount of new information out there, and helping people that are regulating wetlands, people that are trying to work around them and protect them. And we also understand where we don't have wetlands out there as well. So you'll see a little bit more from Mike on this piece. But again, they're filling in gaps that we've been missing for decades, and not being able to protect, in this case, very, very important terrestrial habitats out there that connect up directly with our aquatic resources as well. But I tell you, the one thing I'm most excited about, and that is one of the biggest challenges we have out there, is working with our agricultural community. Again, mainly family farmers out there, about 87,000 family farms covering a good portion of the Chesapeake Bay watershed out there. Here's how we, sort of in the past looked at it. Okay, it's a nice landscape, and you can see different farm fields out there as well. The work of the Conservancy added this layer. And what you're looking at is essentially elevation data. And it's allowing us to not only look at these as farm fields and parcels, but most importantly, as small catchment basins, as small watersheds, and to actually work with those landowners and say, here's the most important place you can put your practices to both protect your investment on your land, on your farm field, in your hayland and grassland out there, as well as protecting water quality for your downstream neighbors out there as well. So now we have transformed what traditionally look like parcels of land out there to catchments, and then we can now look at, in this case, multiple fields out there. And again, it could be adjacent landowners, different ones, or all the same, to then take this information and sit down with them and understand what's happening. This is a tool we have never had until the last decade, and the transformable work that the Chesapeake Conservancy and its partners have come up with. And then finally, Carly Dean and the team that's working up in Pennsylvania to help Pennsylvania test out these methodologies and start actively delisting their programs. They actually have maps that no longer then just say ag land. They actually are able to look at individual parcels. They're actually able to look at little individual catchment basins. They're able to look across their fields and look at an integrated solution to, where do I need to put this practice? Where can I help my local streams? But most importantly, how can I ensure that my crops, that my livestock, et cetera, are healthy, that I'm getting robust yields from them. At the same time, I'm putting practices in meaningful places out there as well. So this is why I think the investments that past agencies like like EPA, my old partnership, have continued to make investments in the Conservancy. Here's where I think we're going to be able to transform how we deliver to agricultural areas. How do we deliver to other conservation groups out there working there? How do we look at the landscape a lot differently than we have for decades out there as well? So I'm looking forward to answering questions out there, as well as continuing my work with the Conservancy as a board member and directly with the CIC as the chair of our subcommittee on that group as well.
Thanks, Rich. That was great. And I'm going to bring in Katie Walker. I mean, Rich did a great job at talking about how our work is being used by the EPA, by other organizations. But Katie, she's the one doing the work along with her colleagues. And so she's going to be telling you a little more about how that's done. Katie.
Awesome. Thank you, JT. And thank you, Steve and Rich, for some of the overview and introduction to the Conservancy at large and our relationship with the conservation movement here in the Chesapeake. As both Rich and Steve alluded to, kind of our organization, in partnership with all of our strategic partners, federal, state, local, nonprofit, even private partnerships, we are really working towards kind of one overall programmatic vision. And some of the key kind of linchpins to this vision that we have identified in the last couple of years are really working for traditional conservation. We're looking to see 30% of the entire watershed conserved by 2030. We're looking to restore 30 streams by 2030. And overall, we're looking to support watershed planning to meet those regional pollution goals that are set, and that kind of timeline is 2025. So with some of these overarching kind of long-term visions, our team is saying, what can we do to help support this? And Rich provided some excellent examples on how this fits into some of our larger federal partnership with the Chesapeake Bay Program Office and a number of the partners involved in that. So I want to take a moment and just kind of walk through what the three of these kind of visions really mean. So the first, conserving 30% by 2030, that's very much a traditional land conservation. How do we make sure that lands are put and permanently preserved for the enjoyment of not just our generation, but future generations? And how we're supporting that is through the Chesapeake Conservation Partnership, which the Conservancy is an active convening member of. We, through the Conservation Innovation Center, have done a number of analyses that are identifying prime agricultural lands, prime forested lands, cultural sites that are of importance. And we take all of that information and stack it against each other. And when you consider it in a spatial context, then we come across with valued landscapes, places that for a number of reasons are valued by the communities that are within the Chesapeake. And we're making sure to include and provide a voice to a number of diverse communities across the entire watershed. So some of those, cultural sites and some of the social layers are making sure that people who have been underserved or underrepresented in some of the decision making, a lot of the data that we're using is trying to enhance their visibility in terms of what is considered a valued landscape. And so we're looking to kind of say, we're over 20% of the goal. So in this last realm, how can we help prioritize where efforts are going to fill that gap, to get to that 30%, what hasn't been restored or conserved, and where can we focus our efforts to make sure that we're saving some of these diverse landscapes and making sure that what is conserved is representative of our entire community. Secondarily, from traditional conservation into restoration, we're looking to ensure that there are healthy watersheds for people to enjoy, both just from the natural beauty perspective, but also from a recreational perspective. And that restoration, as Rich mentioned, my colleague Carly, and the work that we're doing in Pennsylvania on the ground with restoration practitioners and technical service providers. We're actually putting practices in the ground in collaboration with landowners to help manage the landscapes and reduce pollution coming across the landscape. So how does our team help support this effort? There's a number of data layers that are going in, as Rich was showing examples earlier and is on the screen on the right, of just trying to understand how water is moving across the landscape. Because with water, you're also grabbing sediment and nutrients off of the landscape and transporting them through the water. So our goal is to hopefully slow down the water so that it's being filtered more, so that there's an opportunity for some of this nutrient and sediment to filter out before it reaches the main waterways. For that reason, again, we want to see impactful events in some of these watersheds, recognizing that restoration can take almost a decade to see any physical changes. We wanted to start setting some long-term but achievable goals so that we can monitor our progress, that we're not just planting trees and putting in water or sediment control basins just to say that we're doing it, but so that we can look back and have some achievable goals. So through the rapid delisting strategy that our colleagues in Pennsylvania have coined and really brought momentum behind, we're looking at some of those and saying, okay, let's strategize. What is a watershed that has a lot of opportunity for implementation, that has significant risk for additional pollution? And if we really concentrate some of the on-the-ground efforts with our other regional partners, how can we really focus in on one watershed at a time instead of spreading our efforts out across multiple different landowners and watersheds, so that this watershed can get delisted, so that in the 5 years from now, we can do a macroinvertebrate survey and see if the health is improving. So we're trying to create more tangible goals, and again, using our geospatial data to help inform where those decisions are happening. And similarly, again, not just our 30 by 30 restoration goal, but in general, we're looking to help the jurisdictions and local partners meet their pollution reduction goals that are set in place in concert with the Environmental Protection Agency by 2025. So with that, again, we're really just trying to drive data-driven decision making. So trying to use data and use geospatial science to say, how can we be informing these efforts so that we meet these very rigorous goals? Opportunistic conservation and restoration, while still helpful, might not be enough to meet the goals by the deadlines that we're hoping to achieve. So we're trying to say, what can we do to make that effort easier? As Rich mentioned earlier, again, we have a really strong partnership with the Chesapeake Bay Program Office. And as Steve mentioned, we have a number of flagship products that we've created over the last several years through this relationship, and are looking to continue developing and refining over the next couple of years. So the first is that we're creating 1 meter land use, land cover data, and we're creating change information over the time periods. We do this in partnership with the University of Vermont's Spatial Analysis Lab and colleagues at US Geological Survey. We initially created this data using imagery from 2013 and 2014. So the data reflects that time period, essentially. And we have since created another data layer referencing imagery from 2017 and 2018, and are currently in the production process for creating data reflective of 2021 and 2022 conditions. So this allows 3 timestamps that we can look across and really note what's happening on the landscape and how things are changing. So if you'll take a look at that leftmost image of land use, land cover, this is a land cover data set. This is a 30-meter resolution data that is the best available national data layer for land cover. And what our team has done is really go through and create it at the 1 meter scale. And as you can see, the detail provided really change what's possible in terms of how you're describing the landscape and how you can really work at a parcel scale to make decisions. That change from 30 meter to 1 meter allowed us to start working with individual landowners and be able to describe a little bit more accurately what's happening on their property, so that we're not just making regional assumptions or kind of generalizing before we get out into the field. We can help prepare ourselves for conversations a lot easier through this. In addition, that information is getting fed to the Chesapeake Bay program, and it's being used for modeling efforts that are looking at how water, how sediment, and how nutrients are moving across the landscape. And again, the more accurate and reflective the data is for the on-the-ground conditions, the better the models are going to reflect, and we can make better estimates on how to track progress. So hopefully, again, we're kind of in the production run for a third time period. The other goal for this is that we're looking at change across the landscape. And so having that third time period will help us also start noting not just where change is happening, but it will help us to start seeing if there are longer term trends that we need to focus on or be concerned about. So the more we get to produce this data, the better we can look at trend analysis, which is something that wasn't able to be done at the 1 meter scale. The second data product that we really focus on is hydrography water data. And so in this image, it's very faint, but the red line was, again, the national standard for data, the national hydrography data set. And that data layer has been used for a number of modeling efforts and decision-making over the years. And our goal was to create something, again, just more reflective of what's happening on the landscape and actually following the channels of the water a lot closer, because again, so much of the pollution is from that land-water interaction. And we're trying to better accurately describe that space so that when we're talking about riparian forest buffer plantings, that we're actually being reflective of where the water is and where the land is, and not just making, again, kind of general estimates from this line. So we have developed a new methodology in partnership with the University of Maryland, Baltimore County. And through this relationship, we're using the best advances in geomorphic hydrography. We're using high resolution LIDAR data, which looks at elevation. And we're basically describing channel-like features on the landscape, again, just a lot more accurately than what was previously available. And our goal is that we're going to have some discussions with the federal government and see if the methodology that we've developed can actually get adopted as a national standard and over time can be used to improve hydrography data sets across more regions so that we can have more standardized hydrography products to make decisions. And with these two data sets, we're using them to support watershed planning and tracking of progress. So we currently partner with two groups, the Commons and Drexel University, where our team is really focused on trying to map and identify opportunities for where management practices can be put across the landscape. And then we're working in partnership with Drexel University to model the reductions that putting those opportunities in the ground could have based off of some of their modeling efforts and coefficients that are backed by the Chesapeake Bay Program Office and are aligned with kind of that federal regulatory perspective. And then we are working with the Commons to put those two components into a platform that is used for tracking progress of implementation practice by a number of grant givers throughout the region. So that tool that was originally used just for reporting progress of practices can also be used for planning. And so all of the information from the reporting efforts can be put back into planning and create that feedback loop so that as new practices are happening in the ground, that information gets fed back and can help drive future planning efforts where there's definitely a lag right now. So we're just trying to make it a little bit more streamlined. And I'll just kind of end my component with saying that, our relationship with the Chesapeake Bay Program Office has allowed us to really drive innovative methodology development where we're creating data that hasn't previously existed at a scale that is achievable for doing individual landowner work and planning. And so we as a team are also taking that data and not just feeding it into kind of our federal and state partners through the program, but we're also kind of looking at other avenues and opportunities for how this data could get used. We've mentioned my colleague Carly and some of the work that's happening in Pennsylvania on the ground. And they are working with a number of watershed organizations, nonprofits, conservation districts to come together using this data and create outreach strategies so that they can go knock on the doors of landowners more effectively by saying, we as an organization will take these landowners and maybe some of our partners like the Chesapeake Bay Foundation will take another set of landowners. So we're strategizing who we're reaching out to try and have the most impact and get better success rates for landowners looking to adopt practices. We're feeding this information and creating web applications, tools, and one-pagers that can be used to help inform policies, regulations outside of just the individual kind of landowner outreach perspective. We're also looking to inform our local decision makers about county policies, about forest conservation, and making sure that our local laws are reflecting our values. And so we've worked in concert with the Forest Service to create county scale fact sheets using this land cover, land use data that are describing forest and tree canopy gains, losses, change, so that we can keep our policymakers informed as they're looking and reading about potential policies that might impact forest conservation. So all of these things kind of come together again, and being a bridge between what's happening at the federal and state level and what's happening on the ground in terms of restoration and conservation, and making sure that we're informing both parties using the same data so that everybody's on the same page. And so I will actually go ahead and pass it to my colleague Mike to talk about a little bit more of, again, the last 10 years of the Conservancy have really been focused on traditional geospatial science. And hopefully our next 10 years are really going to be thinking about how we can innovate and create methodologies that are leveraging the best available technology.
Thanks, Katie. Appreciate it. And I'm bringing up Mike here to talk about his work. I can't tell you how valuable the information that Katie is describing here. That you have all this data, they could look at what the land use is for several states, but for each jurisdiction, even each property owner, to know that what they can do and make a difference is so valuable, because we know that there's not a one-fits-all approach. And so we can be able to provide this data, and Katie and her team can be able to produce it. But as you know, the pace of change is so great with climate change, with development throughout the watershed, that having precise, accurate data in a timely manner is a huge help to so many of us who are in this work. But what if we could get faster? What if we could potentially predict a lot of this? And this is where Mike and his work with his colleagues come into play here. So Mike.
Yeah, thank you, JT. I'm excited to share, as JT had mentioned, some of the very newest and most cutting edge tools and approaches that we're using to take the work that the Chesapeake Conservancy has done in partnership with other organizations that we work with, and make it even more effective. So what I want to do today, my goal is really to pull the curtain back and share a little bit about some of the tools and techniques that we're using in our latest analyses. And so there's 3 domains that you've gotten a sneak peek of at this point that I want to touch on. And these are developments in remote sensing. So the amount and quality of remotely sensed data imagery of the Earth that we have available, combined with techniques in artificial intelligence that we have been leveraging, and using both of these tools in conjunction with advances in cloud computing. This intersection of these 3 technologies, as they have matured, have now allowed us to change the way that we're answering 2 very fundamental questions, which is, where are the things that we care about, and why did they appear where they did? So this has been the suite of tools and the guiding principles behind some of the projects that I'm going to share with you. So first, a little bit of terminology, I suppose, background on what we're talking about when I say remote sensing. We've been looking at a lot of images, satellite imagery of the Earth, and this is obviously fundamental to the work that the Chesapeake Conservancy does. So remote sensing just refers to data about the Earth's surface, and it's usually collected by a satellite or plane. You're probably most familiar with images like the one that you're seeing here of the Earth's surface. And something to emphasize, though, is that these images actually contain a lot more data than meets the eye. So instead of being sort of a static 2D picture, these images actually have multiple types of information about different parts of the electromagnetic spectrum. So every pixel in this picture has information about red, green, blue, and even invisible infrared reflectance. And these images can actually contain data that has nothing to do with what we would think of as images. They can contain radar returns and LiDAR laser returns that give us different types of information about the Earth. And one of the coolest things about using remote sensing data, as Katie was just pointing to, is that we don't just get one snapshot in time. Many of these data sets have been collected over long periods of time. So we can use them to track not only current conditions, but historic changes and trends as you're seeing the development of Annapolis play out right before your eyes. There's so much data, actually, that the limitation of effectively leveraging it for conservation has in the past been the sophistication of algorithms and analytical tools that we had to extract meaningful information from remote sensing data, which is where our work with deep learning and artificial intelligence has come in. So there's a lot of different terms that get thrown around in the AI field. I'm going to try to limit myself to using just the two, AI or deep learning. And deep learning refers to this type of predictive model that we've been developing, and the whole world seems to be developing, which uses a structure called a neural network. I'm showing this here. This is the very basic structure. And the idea behind these deep learning neural networks are you have individual neurons, which are the circles in this image. And each of those neurons takes multiple types of input, multiple variables, performs a little calculation itself, and then passes its output on to another set of neurons further in the network. So you get this really dense, interconnected framework by which variables are transformed, calculated, recalculated. And this approach is really good at learning complex relationships between input data, like the bands of a remote sensing image, and some, output, perhaps in this case, the classes of land cover in the maps that we're trying to produce. So this combination, of deep learning and remote sensing has been really transformative to the work we're able to do. Concretely, what does it mean? What we're able to do and what we're trying to build are AI systems that can take an image like the one you're seeing here and automatically identify something we care about, like wetlands, as Rich was pointing to earlier. And the systems we're developing can do this in an automated, repeatable, and scalable fashion. They also do it oftentimes more accurately than the data that we had before. So what you're seeing here are a comparison of sort of the current standard national data set for wetlands in green and outputs from our AI wetland model in purple, side by side in the same location. And so if you focus on the one on the top left, this illustrates one of the advantages of using remote sensing data in AI. So those green blobs and lines clearly represented wetlands at some past point in time before those parking lots and buildings appeared. By using remote sensing data that's collected repeatedly and currently, we can use the systems, these tools that we're developing, to update our maps of wetlands to more accurately reflect conditions on the ground at any moment in time. So all three of those panels on the left side of the screen are sort of showing this temporal mismatch between old out-of-date data and then what we're able to detect using AI. The series of images on the right is just illustrating how our AI models are in many cases more accurate, finding wetlands that were missed in those old national data sets. And this work actually it was just recently published. We're very excited about this in a leading scientific journal. So as Steve was mentioning, democratizing data, we're trying to make these data methods and models publicly available so that we can share them with partners that can use them to impact real change on the ground. So the other advantage that I wanted to highlight about this mashup of AI and remote sensing data is the speed with which we can do this. So it might be fairly daunting to look at an image like this and try to find all the solar arrays. This is a question that is increasingly coming up in conversations. where is solar being built. And we can develop AI models not just to find wetlands, but we can develop them to very quickly find all the solar panels in a given image, whereas a human would take, I don't know, it would take me several hours to find and draw polygons around all those solar panels. Now imagine trying to do that for an entire county, for a whole state, or even the whole watershed. This is where the third pillar of technology that I mentioned at the top of my time here, cloud computing, really comes in. Historically, what someone working with remote sensing data and producing even AI analyses would have to do is go to a bunch of different online sources and collect data sets, download them to a local machine. This is moving huge amounts of data and is incredibly inefficient. Then our developer writes some code that is going to run an analysis, again, all on one sort of local desktop machine, which takes a long time, and we get hopefully a useful map out of that process. This is incredibly inefficient. It involves moving massive amounts of these remote sensing images that cover, the entire watershed, needlessly moving them from where they're stored online to our local machines. And often the computers we have are not powerful enough to even handle the analysis. The framework that we have been able to shift to with strong partnerships and taking advantage of new resources that are available is moving these analyses to the cloud. So what that means is we are able to access farms, dozens of computers that live in Microsoft or Amazon or Google data warehouse, shown on the left there. We send our code off to those machines, and they are often the same machines that are storing catalogs of remote sensing data. So now the imagery and the computing power are in the same place. And because we are leveraging, like I said, farms or many different virtual machines, those images can be broken up into smaller pieces, analyzed, and then all we get back is our output map that we're using for conservation purposes. So this is much more efficient and has really enabled us to run these types of analyses at scale. A great example, well, let's see sort of what this looks like in action. This is just an example of the code, the script, and then sending that off to different virtual machines to process imagery in chunks. So each bar that you're seeing here is a different computer that does not exist at Chesapeake Conservancy, working on its little piece of imagery and running our predictive model. And so this is how we map solar arrays across the entire Chesapeake watershed, not just in a current time step, but back through time. So we're able to leverage cloud computing to take all the imagery from these 7 states in DC and quickly get a map of solar arrays, again, not just currently, but every year going back to 2017. These kind of data are fundamental to helping us answer that second question that I posed, not just where are the things we care about, but why are they there? You need, in the case of solar, to have the trajectory of where it was built and when it was built. And now that we have this information, we can actually look at the characteristics on the ground where solar was built and when, and where it wasn't, and begin to understand, well, what is the driving cause of solar sighting being in certain places. And this work actually is about to be published in another scientific journal, so we're very excited about that. And it's led to one of the most, in my opinion, exciting outcomes from the current work that I've been involved in, which is taking this ability to map things on the ground, things that we care about, things that are important to conservation, and start to anticipate and predict where they're going to be in the future, how our conditions going to change. So with those solar data that we generated with AI, cloud computing, and remote sensing data, we're now able to create a heat map like the one you're seeing here that is showing the places that are most and least likely for solar to be developed in the future across the entire watershed. And this is information that we think is going to be really important to combine with other data to anticipate the footprint and conservation impacts of solar moving forward, because we know that it is going to continue to grow. And again, along the lines of democratizing data, those solar array maps that we created, along with these predictive outputs, we make publicly available, and our web developer, Alicia, is doing a great job of making a really cool interactive web app so that others can visualize them. So I wanted to end my time here just by sharing some of the future directions for this sort of next generation precision conservation work. Like I said, we're very excited about the tools that we have and see many different applications for them. So we want to strengthen and continue, obviously, our relationship with the Chesapeake Bay program. And so there's 2 projects upcoming where we are going to apply these techniques. And these are to map, to attempt to map land cover, which has been so foundational and important to the work that we've done using AI. We've also been talking with folks at USGS to map animal feeding operations, which have a tremendous impact on the kind of nutrient and pollution runoff. Excuse me, I apologize for this slide advancing itself. Animal feeding operations are really important to understanding water quality dynamics in the bay, and then also moving towards real-time monitoring. So very quickly, what those would look like is, again, using our AI and remote sensing processes to take high-resolution images like this and develop an AI system to create those land cover maps, again, quickly, automatically, and repeatably, so that we can do this whenever there's new imagery available and keep that information as up to date as possible. Here's some just very teaser examples from our efforts to map animal feeding operations. We're designing a system to, again, take imagery and identify not only the sort of footprint of buildings involved in these operations, but also return a prediction of what kind of operation the AI system thinks it is. This would be a completely new and revolutionary data set that we could share with the Bay program. So we're very excited to continue working on that. And we have also been exploring, as I mentioned, really pushing the cutting edge of marrying AI and remote sensing data to implement real-time monitoring. So instead of needing to wait potentially several years for new imagery to come out and new maps of land cover to be created, there are systems of satellites collecting images of the Earth every 5 days. And so if we have a system for change detection that we're confident in, we can take a picture from 5 days ago and compare it to the most recent picture, such as what you're seeing here, and automatically identify changes to land cover that are meaningful, in this case, caused by humans. So I'll play that back once more. We have a picture from May, picture from July, and the idea is for AI to be able to detect in near real time what are the changes that are happening on the ground so that we can keep up to date with what the conditions within the watershed are. So I think with that, I will stop, and hopefully we have some time left for questions. Is that right, JT?
Yeah, we have a few minutes left for questions, so you can put them into the question and answer field, and I'm going to bring everyone else in here, our panelists back, to answer any questions that we have. So I had a quick question, just to start things off, is for Katie and Steve, if you could talk a little about when we're approached by a municipality, neighborhood, a small town, who wants to utilize some of this data. What does that look like? What are some of the things that they have requested, and what services is the CIC team able to provide?
We get a lot of requests from conservation groups, and one of the ones that we're dealing with, and they're looking for, where should they invest money, or where should they write grants for easements to protect watersheds, to plant trees, where these opportunities exist within their watershed. So that's just one example, and we're actually working on a grant to be able to do that in multiple communities. Again, just, some of the latest information on climate change is that trees are the best natural solution for addressing, carbon sequestration. So we're trying to increase the number of trees within the whole watershed, and figuring out where they can be planted without heavy impacts on farming or other types of land use is part of what we do on a regular basis, leveraging the data that you saw. Katie, other examples you might want to share?
I think you did a good job there. And I would, I guess I would just add that, in addition, sometimes when we've talked with folks, sometimes it's through a webinar like this that somebody sees and gets a spark. And we've done, tree canopy analyses, solar sighting, I think that for the most part, it's leveraging the information, again, just to say what types of decisions need to get made and how can we use the high resolution data in order to do that, to describe either the land use, land cover change, how water is moving across the landscape, or even with some of what Mike is doing, kind of new feature identification, ways that we can describe where a particular feature is across a wider range of a geography.
Well, JT, one of the biggest things that we're doing over the last few years is a lot of the environmental modeling that the states and the federal agencies use. We're actually updating those models. We just updated hubs and corridors for wildlife habitat in the state of Maryland that hadn't been updated since the late 80s. And it was based off of the national wetland, the national hydrological data, old data. So we're bringing in this new data that's very reliable, high resolution, and we're totally revising their models, which is giving them much more current and accurate information to make their decisions.
All right, thank you. And just to look at a few questions here in the chat. Question for you, Katie. What does delisting mean in terms of stream delisting, and why is it important?
Yeah, absolutely. So the regulatory groups, state agencies, federal agencies, have standards for what it means to have a clean waterway. So some of these streams get onto a list of non-attaining, meaning that there is some type of pollutant or toxic contaminant, some reason that it's not meeting safe and clean water standards. For a lot of the waterways in the Chesapeake, that's mostly because of sediment and nutrient pollution. So whether it's, there's a variety of sources that pollution is coming from. In order to delist, what that means is that we have put enough practices on the ground to reduce the incoming pollution to that waterway enough that it will start meeting the standards for safe and clean water again. For the most part, delisting happens by a biological scientist going and conducting surveys of the critters and macroinvertebrates that are there in the waterways. And so for our delisting strategy, again, we're kind of hoping that because it takes a number of years to see any changes on the ground impacting the actual kind of life in the water, that what we can do is put enough practices in the ground now so that 5 to 7 years from now, when the streams get reviewed again and the biologists are actually going out in the field and doing these surveys, that we have done enough that we're seeing the species that are indicators of healthy and clean watersheds.
Thank you. And our last question here for Mike and Katie: are cultural resources such as historical sites or past tribal lands able to be integrated in GIS data sets, and how is that information shared with local landowners and jurisdictions?
Yeah, so that type of information is definitely usable in GIS, and sometimes that data has already been put together. So we interact and use data from a variety of sources. The best available, there is a national kind of data layer that looks at cultural and historical sites as well as protected areas. And this information shows, kind of records of things that have been noted. There are sometimes local layers kept at the county scale that have more than what the state or the federal agencies might deem valued or important from a cultural perspective. But pretty much as long as we have a point we can keep a record of where some of those sites are. And as I had mentioned, through our relationship with the National Park Service and the Chesapeake Conservation Partnership, those are data layers that we have used in the past. A lot of that information is used to describe what are valued landscapes for the conservation goals that we've set. So for some of that, we're already doing it. And again, what I have mentioned is that in the last couple of years, we've been doing a concerted effort to add additional data information about kind of diverse values and communities that might not be as represented in some of the state and federal data layers. And so that's something that we work with individual communities to help identify and prioritize, because obviously we don't know all of the cultural information for every state or every county in the watershed personally, but we can make relationships and partners with some of the folks that are more local and have that knowledge when we do analysis.
Thank you. All right, we're going to wrap up here. And I just wanted to, again, thank you all for attending our webinar today. We appreciate your interest in learning more about the work that we're doing at the Conservancy, and in particular, the Conservation Innovation Center. And we love your feedback too. If you have any thoughts on future opportunities for webinars, this is part of our webinar series that we're doing throughout the year. So if there are any topics that you would like us to address that you're interested in, let us know, and we'd love to set up a webinar for it. And as some piece of housekeeping, we do have several events coming up for all of you to be a part of over the next several months here, including hikes, other webinars. And part of it is under the umbrella of what we're calling our Saving Special Places Week. That is our spring fundraising drive that we have in the first week of June, coincide with Bay Awareness Week, where we raise funds for the special places that we care about the watershed to be able to protect them. And we're hoping that you can be involved in it, either through your contribution or as an ambassador to reach out to your network. We can set up a fundraising page for you, and you can help us in our mission here. We also have events going throughout that week that we'd love for you to participate in. On June 3rd is a plant swap that we have in Baltimore City. And on June 7th is going to be our next webinar featuring our work that we're doing at Phones Cliffs with the Rappahannock tribe as a model for indigenous-led conservation, returning the land back to the tribe, but also as a model nationwide for being able to manage this land along with the Rappahannock tribe, Fish and Wildlife Service, and other entities in the area. And then on June 10th, we have a hike at Patapsco Valley State Park. It's also going to be a ribbon cutting for our bilingual ranger station that's being led by several of our bilingual rangers. And all these feature the various aspects of the work that we're doing here, made possible by your support. And we couldn't be happier to have your support, your interest in protecting the bay, because this is what it's all about. And we look forward to staying in touch with you. We'll be sending out this webinar recording in your email, along with a few other links and things that were referenced throughout this video. Let me know if you have any other questions, or are there any questions that were not answered that we'd like to have our experts go into. And I want to thank you all once again. So take care.
Thanks, everybody. Take care. Bye-bye.